Hi everyone, and welcome to the second part of this tutorial on conversational interaction with social robots. In this part, we will look at how to program conversational interactions with the Furhat SDK. So, using the Furhat SDK, there are actually different ways of programming the Furhat robot. And if we look at it, that we have the most sort of fundamental things that you can control with the robot. So you can make the robot say things, you can make the robot do gestures, you can shift the attention, and listen and access the users that are in front of the robot and so on, and the LED of the robot. If this is the only thing you want to control, and you might have already perhaps another conversational system that you want to connect to the robot, there is something that we have recently developed, which is the remote API. And there you have access to this basic input-out functionality. And it's polyglot in the sense that you can actually do this from a lot of different programming languages, including Python, C#, and so on. I think it's over 30 different languages that are supported. But what I will talk about mainly today is how to use the skill framework. So the skill framework is something that is we have built on top of this, which is a much richer framework for developing conversational interaction, where you can develop a dialogue flow. You have access to natural language understanding, multimodal utterances, Wizard of Oz functionality, and also to add graphical user interfaces to the robot. And this you can program in two different ways. So we have what we call the Kotlin Skill API, where you use Kotlin, the programming language, to program the robot. And then there is also the Blockly graphical tool. And these two are sort of similar, but clearly the Kotlin Skill API is much more powerful because you can program it and use a lot of different other libraries that you want to combine with the robot and APIs and so on. Whereas Blockly is a bit limited, but it's of course very powerful if you want to explore what the robot can do. Or if you only need to create more basic interactions, for example, for Wizard of Oz and so on. And since this tutorial is a bit limited in time, we will actually use this Blockly graphical programming tool so that you can experiment with that because you can do it and get started very quickly. So as you will see, the Blockly programming tool is basically you have a toolbox with different blocks representing different triggers. For example, the user saying something and then defining actions that the robot should do. For example, saying something back to the robot, to the user, or attending somewhere and so on. And I will also in this presentation talk a bit about the Kotlin Skill API because that's very good to know what sort of the potential of the platform is. If you want to do more programming with Furhat, you should definitely explore that. So why have we chosen Kotlin for our Skill API? Well, Kotlin is a very powerful programming language. It's based on the Java platform, so all the libraries that exist for Java can be used from Kotlin. It's developed by JetBrains, which also developed the IntelliJ IDE, so it integrates very well with that, and it makes it very powerful when you program it using this. It's actually Google's preferred language for Android app developers since May 2019. So there are others who have recognized how nice Kotlin is for developing applications. It has some language features that I find very useful, and it's statically typed, which means that you get very nice code completion and so on. and it has type inference and extension functions. It also has support for what we call domain-specific languages. That makes it very powerful when defining dialogue flows and gestures and utterances for the robots. So to understand a little bit better on how you actually develop interactions with Furhat, let's look at this very simple example. Let's say we want to create a robot that sells fruits. And this is actually a tutorial that you find on the Furhat website. If you try out our tutorial, you will find exactly an example of how to do this and how to program this in Kotlin. So in this dialogue, we might have a user approaching the robot, which sells fruits. And the robot says, "Hi there." And you say, "Hello, how about some fruits? What do you have?" "We have banana, apple, orange, and cherry moya. I would like 2 bananas and 3 apples." 2 bananas and 3 apples. What a lovely choice. Anything else? "Well, I changed my mind. I don't want the bananas." "Okay, let's remove that. Your current order is 3 apples. Anything else?" "No, thanks." "Okay, here's your order of 3 apples. Have a nice day. Great day." So then is the question, how do we approach this? How do we define this interaction? Well, a very, very useful way of looking at this is to define the different states that you go through in this interaction. And then we can develop this using a state chart formalism. So the idea is that we have these different dialogue states. So first we might be in an idle state where the robot is basically just waiting for someone to walk up to it and interacting with it. And then someone approaches and we are in a starting state where we greet each other. And then we are in a taking order state where we are taking order from the user. And once we're done with the order, we ask if there is anything else, and we might add or remove things from the order. And we are still in the anything else until the user doesn't want anything more, and we are back to the idle. So if you write down your dialogue, you can define the states, and then you can figure out what this sort of state chart look like. You can see how we transition between these different states and then go between them like this. And then you can define sort of what are the things that the user say that makes, or other things that happen that makes the system transition between these states. So often it's something that the user says, but it could be, for example, something that happens like this. We are in the idle state and the user enters, which means that the user stands in front of the robot, and that makes us transition to this start state. And the fact that the user greets the robot takes us to the taking order state, and the fact that the user wants to buy a fruit takes us to anything else. And here we can either buy fruit or remove fruit, and then until the user says, "No, I don't want anything else," and we go back. And we can see here how what the user says here is mapped to these so-called intents. So this is what the natural language understanding does. It takes these words from the user and maps it to these intents, which is the underlying intention of what the user wants to do. A very, very powerful thing here that we can do in this is to also define these states in a hierarchical way, which means that we define a very abstract dialogue state, just like you inherit classes in a sort of object-oriented programming. You have some kind of super state, and then you have other states which sort of inherit this. And it means that we can define these kind of triggers on one level, which are inherited on lower levels. So for example, request repeat, which represent the user saying, what did you say? This is something that you could say in any state, regardless of where you are. So we define that on our top level here, and then we inherit that intent on all levels here. This means that when we are in the start state, the user can either say greeting or request repeat. If we are in the anything else state, the user can say all of these things that are relevant in this hierarchy. And that means that we can define sort of reusable things on different levels in this hierarchy. When you program this in Kotlin, it's quite straightforward using this domain-specific language. So here's, for example, our idle state. We say that on entry, which means that when we start this state, we want Furhat to attend nobody. And when the user enters, we want Furhat to attend that user and then go to the start state. So we define these triggers with different things that should happen. When we are in the start state, we want Furhat to ask, hi there. And if the user responds with a greeting, we want to go to the taking order state. If you program this with Blockly, you will see that it's actually exactly the same structure, but you're using these graphical blocks instead of this Kotlin code. So we have the state and we have a trigger and we have the attend here and the go to and the ask hi there. So it's exactly the same structure that we saw here in the Kotlin example, but you use the graphical tool instead. So intents, I mentioned that the natural language understanding is based on intents, and there are a couple of different built-in intents that you can see here. These are very common things that users might say, but you can also, of course, define your own intents. And then we have entities, which are like semantic units within these intents. So if I want to order a trip, for example, that might contain a time or a date or a number and so on. So if we look at the example of how you define this, in Kotlin you can define this. You can also define it in Blockly to define your own intents. For example, the buy fruit intent here, and you provide examples of what the user might say in order to buy a fruit, and you define that you have this fruit entity in here. And even if we have provided examples like banana, I want an apple, or I would like some oranges, it would also trigger if the user says, I would like an apple. And here is from another example. We are, however, ordering a trip. So I'd like to go to London, let's see, on the 1st of August. Here we have a departure, a destination, and a date. And you define this in using the Kotlin code or Blockly. Another thing that is important in this kind of social robot interaction is to manage users, because we might have several users which might enter the interaction and leave the interaction. And this is done by having this interaction space that you will see when you use the SDK. And if a user enters the inner space, we have an on-user enter, which informs this event informs Furhat that Furhat can start interacting with the user. And when the user leaves the outer circle, we have a leave on user leave event. If you use the Kotlin code, you can actually specify how you want this engagement policy to look like, using the different parameters for how many users you accept and so on. In Kotlin, you might access through these different functions a list of all users that are engaged and which is the current user, and so on. You might also store data with the user. So for example, if you want to keep track of what is the current game score, if you are playing a game here, a quiz, for example, you might want to keep track of that score for that agent. Or in the case of a user ordering fruits, you might want to keep track of how many fruits or which fruits this specific user has ordered so far. We can also control Furhat's attention, and this can be done both in Kotlin or in Blockly. We can inform Furhat to attend a specific user, in which case Furhat will continue to look at this person when the user moves around. We can attend nobody, which means that we are not attending any specific thing. We can attend all, which means that Furhat will attend all users and shifting attention between them. And we can attend a specific location, which is a point in space like this. Or we can ask Furhat to just glance at the user. We can also detect user attention. So if we want to know whether someone is starting to attend Furhat or looking away at something else, we can catch that with this kind of events also, the sense user attend event. which might be useful to know whether they are actually looking at Furhat or not. We can also make gestures, so we can perform different gestures. There is a gesture library, for example, this big smile or the express disgust that we can ask Furhat to do. We can also add different strengths and duration to these gestures. We also have some functionality for detecting gestures in the user. So for example, we can do this on user gesture, smile, and to detect when the user is smiling and then ask Furhat to smile back to the user. We can also define multimodal utterances that Furhat should speak, where we mix text that should be spoken with gestures at certain places in this text, or make Furhat glance at a specific location in the utterance. And this can also be defined and put in a variable like this greeting here and then reused here, or with parameters. So if you want to say, Furhat say tell price 500, we would define it in Kotlin like this, and Furhat would say it costs $500. Finally, there is a Wizard of Oz functionality. So you can, both in Kotlin and in Blockly, easily add buttons that you want to trigger certain events. So for example, here we can add a button with the label attend other user, which if pressed would make Furhat attend another user. And then in the dashboard of the SDK, this button would appear so that the wizard can press this and control the robot. And this means that you can actually mix this kind of buttons and manual control of the robot with automatic things that you want to happen. So you can actually have sort of a semi-automatic system. So that concludes, and it's a sort of a very brief overview of what kind of things you can do with the Furhat SDK. And now for the third part, you will be able to try out yourself what it's like to program Furhat using this Blockly programming code. Thank you very much.